Ever wondered what multi-protocol label switching is and how much it costs? Let's start by unraveling this tech jargon, shall we? Multi-protocol label switching, or MPLS for short, is a protocol for speeding up and shaping network traffic flows. It's like the traffic cop of the network world. Imagine a busy intersection, with cars representing data packets. Without a traffic cop or traffic lights, the cars would bump into each other, causing a gridlock. But with a traffic cop or traffic lights to direct the flow, cars can move smoothly and quickly to their destinations. That's essentially what MPLS does for network traffic. Now, you might be wondering, why the term multi-protocol? Well, it's because MPLS supports multiple network protocols. It's like a chameleon adapting to different traffic types, be it Ethernet, ATM, or frame relay. The primary goal of MPLS is to make the network smarter and more efficient. It does this through something called label switching. Think of these labels as post-it notes attached to each data packet. They tell the routers where to send the data packets, which path to take, and how fast to go, making the whole process faster and smoother. But MPLS is not just about speed, it's also about quality. It gives network operators the power to differentiate between types of traffic. For instance, they can prioritize voice and video traffic, which are sensitive to delay, over less time-critical traffic, like emails. This ensures a better user experience. And let's not forget about scalability. As your network grows, so does the complexity. But with MPLS, you can easily scale your network without adding to the complexity. It's like adding more lanes to a highway to accommodate more cars without causing a traffic jam. So, there you have it. A quick introduction to multi-protocol label switching. It's all about directing traffic, ensuring quality, and making your network scalable. Now that you know what MPLS is, let's delve into its cost. So, how much does multi-protocol label switching cost? This is a question that's been bouncing around in the minds of many. Well, let's delve into it. The cost of MPLS, like many other technologies, is influenced by a variety of factors. Bandwidth requirements, the number of locations, and the level of management are all variables that play a role in the final bill. Let's start with bandwidth requirements. The more data you need to move, the wider the highway you need to build. In other words, higher bandwidth requirements mean a larger MPLS network and naturally a larger price tag. So if you're running a multinational corporation with data-intensive operations, brace yourself for a hefty bill. But if you're a small business with modest data needs, the cost will be significantly lower. Now let's talk about the number of locations. If you have just one office, then you're in luck. The cost of MPLS for a single location is relatively low, but if you're running a sprawling enterprise with offices scattered across the globe, the cost will rise proportionately. Each additional location adds to the complexity of the network and therefore the cost. Finally, the level of management can also impact the cost. If you have an in-house team of network engineers who can manage the MPLS network, you could save a pretty penny. However, if you need to outsource the management to a third party, be prepared to pay for their expertise. So you see, estimating the cost of MPLS isn't as straightforward as plucking a figure from thin air. There's no one-size-fits-all price tag. Each business has unique needs and circumstances, and the cost will reflect that. However, understanding these factors can help you make an educated guess. Consider your bandwidth needs, the number of locations, and the level of management required. These elements will give you a ballpark figure, a starting point to gauge the potential cost. So, while there's no one-size-fits-all price tag, understanding these factors can help you estimate the cost. But why invest in MPLS? What are the benefits? Let's delve into that for a bit. At the top of the list is improved performance. Multi-protocol label switching optimizes network speed and performance by using short, fixed-length labels to route data. Traditional IP routing involves each router independently determining the next hop in the path, a process that can cause delays. With MPLS, the path is predetermined, allowing for a more efficient data flow and reducing latency. This means your data gets where it needs to go faster and more reliably. Speaking of reliability, that's another significant benefit of MPLS. Its ability to manage network traffic means it can automatically reroute traffic in the event of a link failure. This rerouting happens so fast that it's often undetectable, ensuring uninterrupted service. For businesses, this can mean the difference between a satisfied customer and a lost sale, making MPLS an invaluable tool. Let's not forget about speed. MPLS is designed to handle high-demand scenarios, and can quickly move large amounts of data. This is particularly useful for businesses that rely on the transmission of high-quality video or voice data, where speed and reliability are paramount. Finally, there's the scalability of MPLS. As your business grows, so too can your network. With MPLS, you can easily add and manage new sites or users without impacting the performance of the existing network. This makes it a flexible solution capable of adapting to your needs, whether you're a small startup or a large corporation. So, in considering the benefits of MPLS, we see a technology that offers improved performance, enhanced reliability, impressive speed, and the ability to scale with your business. It's a robust and flexible solution that can handle high-demand scenarios and ensure your data gets where it needs to go quickly and efficiently. With these benefits, it's clear why MPLS is a popular choice for many network engineers. You may have heard of the best effort model, but how does it relate to MPLS? In the world of networking, the best effort model is like a postal service that doesn't guarantee delivery times. When you send a packet of data, it's dispatched with the hope of reaching its destination in a timely manner. However, there's no assured delivery time or priority for your packet. It's simply sent on its way to fend for itself amid the swirling storm of internet traffic. Now, contrast this with multi-protocol label switching, or MPLS. Imagine MPLS as a premium courier service, where your packet is given a special label, a kind of virtual VIP pass, if you will. This label allows it to be fast-tracked through the network, bypassing the congestion and ensuring a speedy and efficient delivery. But the benefits of MPLS don't stop at speed. This system also offers a high degree of reliability. With the best effort model, packets can get lost in the chaos, leading to dropped calls or buffering videos. However, MPLS provides a dedicated path for your data, significantly reducing the risk of packet loss. And then, there's the matter of efficiency. In the best effort model, packets are sent haphazardly, each taking its own route and arriving at different times. This can lead to jitter and latency, particularly for time-sensitive data like voice and video. But with MPLS, all packets belonging to the same data stream are sent along the same path, ensuring they arrive in the right order and at the right time. So while the best effort model is like a gamble, banking on the hope that your data will reach its destination eventually, MPLS is a calculated strategy. It's a way of taking control of your network traffic, ensuring that your data gets where it needs to go, when it needs to get there. So while the best effort model has its place, MPLS offers a more robust solution for network traffic management. So, how does traffic move in an MPLS network, you might ask? Well, at the heart of it all is a nifty concept known as label switching. This ingenious technique is what makes MPLS a standout in the world of networking. Label switching, simply put, is a method of routing network packets. In an MPLS network, packets aren't just sent on their merry way, hoping to reach their destination. Instead, they're assigned a specific label, a kind of digital name tag, if you will, which guides them on their journey through the network. Think of these labels as detailed instructions, like a GPS for your network traffic. They tell each packet exactly where to go, which path to take, and how to get there. These labels are assigned by a label edge router, or LER for short. The LER is like the traffic director of the network, ensuring each packet knows its route before it sets off. Once a packet has its label, it's sent into the MPLS network. As it travels, each router it encounters, known as a label switch router, or LSR, reads the label and determines the next hop for the packet based on the information it contains. It's a bit like a relay race, with each router passing the baton, or in this case, the packet, onto the next until it reaches its destination. But here's the real magic of MPLS. Because the decisions are made based on labels, not the packet's data, routing is incredibly fast. It's like having a fast pass at a theme park, zipping past the queues and getting straight to the fun. This efficiency is why MPLS is so widely used in modern networks. And what happens when the packet reaches its destination? The label is removed by the egress router, and the packet is sent on to its final destination. Just like that, from start to finish, the packet has been guided by its label, ensuring a speedy and efficient journey through the network. And that's how MPLS moves traffic efficiently and effectively through a network. So, we've covered a lot about MPLS today. We've learned that multi-protocol label switching, or MPLS, is a routing technique that speeds up and shapes network traffic flows. It's a highly efficient and scalable solution that's significantly more cost-effective than traditional networking methods. We've explored the numerous benefits MPLS brings to the table, including improved performance, increased speed, and superior reliability. We've also delved into the best effort model, understanding how MPLS goes beyond this model to ensure data packets are not only delivered but also prioritized based on importance. We've seen how traffic is smartly moved in an MPLS network, using labels to guide data packets along predetermined pathways. This results in a streamlined, efficient network that's ready to handle the demands of modern digital environments. With its cost efficiency and network performance benefits, MPLS is indeed a worthy investment for any network engineer out there.